Hey, so this is just a video wanting to show you how to use the z-table if you weren't here or if you just need a recap. So we did these problems. We were finding probabilities or proportions. So like, for example, if we select a female walrus at random, what is the probability that her weight is less than 600 kilograms? And we were told up here that the weights were normally distributed with a mean of 812 kilograms and a standard deviation of 67. So the first thing I'm always going to do on any problem like this, sorry, I'm going to mute that because that's annoying, is draw a normal model and shade what we want. So I'm going to draw a quick little normal model shape. It doesn't need to be perfect, it just needs to look something like a normal model. I'm going to mark the mean. We also talked in class you could go through and find your 3 different standard deviation numbers on each side by just adding and subtracting the standard deviation of 67 3 times on each side, but I'm not going to label those just because saving time. So we want to know less than 600. 600 is pretty far below 812. If we had actually labeled these numbers, we would see that. This number right here is 611, so 600 is below that even. So it's pretty far down there. And then we want less than that, so I'm shading below. So this kind of little picture is showing me that this answer should be pretty small. The next step is to find a z-score for that number. So our observed value is 600 minus the mean was 812 divided by the standard deviation was 67. So the mean and standard deviation were both given to us in the problem. And then we calculate what that is, which I happen to know is negative 3.16. So once we find a z-score, this is where we're going to use our z-table. So my z-table looks like this. It looks crazy complicated, but I promise you it's not that bad. So along the row and column headings, we have the z-scores, and then on the inside of the table are the proportions for each z-score. So I have a z-score of negative 3.16, so I'm going to look for, along the left side, I'm looking for negative 3.1, which is right here. And then I just need to move my finger over until I'm underneath the 0.06 column. So negative 3.16, and then this is our proportion for that z-score. So going back to my problem, I can now write that the proportion that is underneath that z-score, that area, is 0.0008, since that's what our z-table told us, or we could write that as 0.08%, so just multiplying the proportion times 100 to make it a percent. Either one is fine. So let's practice another one. I'm going to draw this out real quick and find the z-score just like we did before. Alright, so I found the z-score and I drew out the picture, and I can see from my graph, or what I've shaded, that this should be a fairly big answer, definitely more than 50%. So I want to keep that in mind as I look at my z-table. So I have my z-score of negative 0.48. So again, on my z-table, I'm going to look for the negative 0.4 row, which is going to be way down here. And then I'm moving over until I'm underneath the 0.08 column, which is this number right here, so 0.3156. So if I go back and I write that, I should have issues with that because I noticed that the area that I shaded is definitely more than half, and the proportion I got is not more than half. So what we have to realize is that on my z-table, and you can kind of see this on the pictures up here, the z-table is always giving us the probability lying below z, meaning to the left or less than, and it kind of says that up here as well. So when I keep that in mind, what I just found that 0.3156 is the area less than 780, which is not what I want. I want the area greater than. So the way we fix that is simply by subtracting from 1. Or you can think of it as we're subtracting 31.56% from 100%, and that will give us the leftovers, which is what's over here, 0.6844. Or, again, we could write that as 68.44%. Either is fine, doesn't matter. And that is how we use our z-table. So moving on, we're going to do one that is between. So hold on. Alright, so I have part H set up. We're finding what proportion of walruses weigh between 700 and 800 kilograms. So I drew my picture, I shaded between 700 and 800, and then I did go ahead and find 2 separate z-scores, one for 700 and one for 800. So now what I'm going to do is I'm going to go to my z-table and find two separate proportions. So negative 1.67 would be 0.0475. And then negative 0.18, way down here at the bottom, is 0.4286. So we've got our two separate proportions. So the way we find the area in between those two numbers is by simply subtracting those two proportions. So notice that I did not subtract either one from 1, even though I'm kind of finding greater than 700 and less than 800. I'm still going to leave them alone. I'm not going to subtract them from 1. All I'm going to do to find my answer is subtract the bigger proportion minus the smaller proportion, right, which gives me 0.3811, or again 38.11%. So the reason that this works is because we are finding a bigger area and subtracting a smaller area. So when I find the z-score for 800, and then I look in my z-table to find that proportion, I am finding this entire area on the graph underneath 800. So everything to the left of 800 forever and ever and ever. But obviously I don't want that whole area. I only want the area between 700 and 800. So then when I go back and find my z-score for 700 and find that proportion on the z-table, what I'm finding is this area, which is underneath 700. So by taking that whole area shaded yellow, that's less than 800, and taking away or subtracting the area under 700, the green part, I'm left with just this little sliver in between. So doing it this way will always work, and it's the most straightforward way of finding a between probability using the z-table. Find a z-score for both, find a proportion for both, and then after you've found both proportions, subtract the bigger one minus the smaller one, and that is your answer. And again, that will always work. The last problem I'm going to show you how to do is one where we're using the z-table backwards, so hold on. Okay, so this last problem is showing us how to, or it's asking approximately what weight will represent the cutoff for the bottom 20%. So what this means is if I were to draw this normal model, it's still the same normal model. It has a mean of 812 and a standard deviation of 67. And what I'm looking for is I want to know what is this weight right here that would represent this cutoff, or the spot where the area below it is 20%. So we're kind of working completely backwards. I know the percentage that I want, and I'm looking for what weight will give me that percentage. So I have to do all of the steps kind of backwards, including using the normal model. So 20% as a proportion is 0.2000. So what I'm looking for first on my z-table, and again I'm looking inside the table where the proportions are, because I don't know a z-score yet, I only know the proportion I want. So I'm going to look through and try to find as close as I can get to 0.2, and these do go in order from 0 all the way down to 1. So I'm just looking for a proportion of 0.2, and I think this right here is as close as we can get. So 0.2005 is about as close as we can get to the proportion we want. So once we find that, we're going to look at our row and column headings for that number to figure out what our z-score is. So there's my number. This is negative 0.84. So negative 0.84 is my z-score. But that's not our final answer, because we wanted to know what weight will represent that spot. So I know the z-score. Now I'm going to use my z-score equation. So negative 0.84 is my z, equals observed. Well, I don't know this observed value yet, so I'm going to leave that as x, minus my mean, which is still 812, divided by my standard deviation, which is 67. And then I just do some algebra, multiply by 67 on both sides, and then add 812 to both sides, and I get negative 0.84. I'm doing this on my calculator here, because I forgot the answer. When I solve for x, I get 755.72 kilograms. We do need to put a unit on this because it is a weight. It's not a percentage or a proportion or even a z-score, so we put a unit on it. The other one, the second one, says top 5%. The only thing you have to do differently on this type of question is just realize that if we want the top 5%, we're going to change a little bit of how we look this up on our z-table. So we want to know what weight down here, or up here, would give us the cutoff to where the area above it is 5%. So when I go look at my z-table, I have to again realize the z-table is always giving me the area below. So if I look up 0.05, which is somewhere over here, right? It's giving me this z-score on the bottom end, and that's not the one that I want. I want the one on the top end. So if there's 5% above, then that means there's 95% below. So I'm going to look at 0.95. There's actually two that are equally close, so you could use either one, 0.9495 or 0.9505, either one. I'm going to use the lower one, whatever. So 1.64 is my z-score. And then we again set that equal to our z-score equation and get a number. So this one's like 922 point something kilograms. So the thing is, this is where common sense comes in. If you know you're looking for the top 5% and then you do all your math and you get an answer that's below 812, that should kind of ring some warning bells in your head, because obviously if you want the top 5%, that should be a number bigger than the mean. So when you get your final answer, always kind of make sure it makes sense with what you were answering, that it makes sense with the picture that you drew. It's easy to make those silly little mistakes of forgetting that you need to look for the top 5 as opposed to the bottom 5. So just always double check your answer to make sure it makes sense. And now I am done talking for today. Have a great day.